Good morning, good evening, good afternoon, everyone. I'm Mrs. Williams and welcome back to my channel. Today's lesson is going to talk about outliers. But before we get into the lesson, I'm going to give you the standard and the essential question to write down in your composition notebook. The standard for today is MGSE 9-12.S.ID.3. I understand the effects of outliers on the center and spread of a data set. The essential questions are: number 1, what is an outlier? Number 2, how do you determine if a value in a data set is an outlier? And number 3, how do outliers affect measures of central tendency and measures of variation or spread? We've talked about outliers in the previous 2 videos, but we never really explained why they were so important. First, what is an outlier? An outlier is an extreme data value. It's the number that doesn't quite fit in with all the rest of the numbers. So let me give you a couple examples so you know what I'm talking about. So let's look at an example. We have 2 data sets here, or 2 lists of numbers. And let's look at the first one. We have 1, 8, 5, 9, 4, and 100. So what would be the outlier in this first data set? Which one is the number that's the extreme value, or the number that doesn't quite fit in? You probably easily figured out that 100 is the outlier. That's that number that doesn't fit in and is really, really big in comparison to the other numbers. So let's look at example 2 down here. Here the data set is 100, 112, 122, 109, 98, and 4. What would be the outlier in this data set? Which number doesn't seem to quite belong? That would be 4. So, an outlier can be a number that's very, very large or a number that's very, very small. But take a closer look. Up here, 100 is an outlier, but down here, 100 is not the outlier. So you really have to pay attention to all the numbers in the list because it's only an outlier if it doesn't fit in. Just the same way here, 4 is the outlier down here. But in the first data set, it's not an outlier. So we really have to make sure we pay attention. So let's go ahead and denote that on the page. So here, 4 is not an outlier. And down here, 100 is not an outlier. So, a number is an outlier if and only if it's the number that doesn't belong in the data set. So let's look at a third example. Can you figure out which numbers in this data set are the outliers? Well, it's probably easy to see that 8,000 is definitely an outlier. It's a number that's extremely large in comparison to all the other numbers. Can you find another outlier? You may or may not have realized, but 13 is an outlier too. So, a data set can have more than one outlier. So from the examples, you see that an outlier can be a number that's extremely small or a number that's extremely big. And you can have a data set that has 2 outliers. But how do we determine if a number is actually an outlier? Just because it's small doesn't mean it's an outlier, and just because it's big doesn't mean it's an outlier either. We have to figure out at what point does a number become an outlier. So let's work a couple of examples to determine how to determine if a number is an outlier. So let's look at the following example. We have to determine if the following data set has any outliers. Well, let's just look at it at first. You might say that 3 and 61 are outliers, but we need to make sure. We need a way to check it. And to check to see if it's an outlier, we simply follow the steps. The first step is to calculate the IQR. And to do that, the first thing we have to do is put the numbers in order from least to greatest. So that would be 3, 10, 14, 19, 22, 29, 32, 36, 49, and 61. So after we put them in order, it still kind of looks like 3 and 61 will be outliers. But again, let's make sure. So to find the IQR, we put them in order from least to greatest. And the second step will be to find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers here. So that means I'm going to have 2 numbers in the middle. And it looks like those 2 numbers are going to be 22 and 29. So to find the median, I will simply add these 2 numbers together and divide by 2. And if you do that, you get 25.5. So this number would be our Q2. And remember, every number below the median is going to be the lower half, and every number above the median is going to be the upper half. So the lower half has 1, 2, 3, 4, 5. 5 numbers, so there should be just one number in the middle, which is 14. And that number is going to be Q1. The upper half has 5 numbers, and the number in the middle is 36. So that number is going to be Q3. And to find the IQR, we will simply do Q3 minus Q1. So Q3 minus Q1, which is 36 minus 14, which is equal to 22. Now our second step to find the boundaries are to multiply the IQR by 1.5. So I would take the IQR and multiply by 1.5. That means 22 times 1.5, which equals 33. So now to find the lower boundary, so the lower boundary, we will simply do Q1 minus 33, which is 14 minus 33, which equals negative 19. So this is our lower boundary. That means any number less than negative 19 is an outlier. So let's find the upper boundary. And to do that, we would do Q3 plus 33, which would be 36 plus 33, which equals 69. The upper boundary says that any number larger than 69 would be an outlier. So let's look at our data set again. 3 is the lowest number. Well, 3 is not smaller than negative 19, so 3 is not an outlier. Let's look at the 61. 61 is not greater than 69, so therefore it can't be an outlier. Hence, this data set has no outliers. So we figured out that just because it looks like it may be an outlier doesn't necessarily mean that it is. So let's look at a very similar data set, but instead of 61 as the maximum, we have 70 as the maximum. And we already calculated that the lower boundary is negative 19. So that means negative 19 is the lower boundary, and 69 is the upper boundary. So that means only the numbers between negative 19 and 69 are acceptable. Any number outside of these numbers would be outliers. So in this case, 70 does not fall within that range of numbers, so 70 would be an outlier. So you see how we can use the IQR to determine if a number is an outlier. And you see that just because a number seems like it's an outlier doesn't necessarily mean that it is. We have to make sure that an outlier falls outside of those boundaries. So why are outliers important? Because they drastically change the measures of central tendency and the measures of spread. If we calculate the mean of a data set with an outlier, then our number is going to be thrown off by that outlier. So if we have an outlier that's extremely big, then our mean is going to be pushed too far up. And if we have an outlier that's extremely small, then our mean is going to be pulled down. And so we're not going to get an accurate answer. However, the median, which is the middle number of a data set, it doesn't take into account the least number or the greatest number. It only looks for the number in the middle. So the median is completely unaffected by outliers. That's why we prefer to use the median if the data set has outliers. It gives us a more accurate answer. Now some of you thinking, well, why can't I just use the mode all the time? Well, sometimes the outlier could be the mode, or you may not have a mode for the data set. So that's why the median is always the best measure to use for central tendency. In terms of spread, the exact same thing goes. If you have a data set with an outlier and you calculate the range, you're probably going to get a very, very large range that's probably a little fluctuated because you have a number that's very, very big or a number that's very, very small. And it gives you a false answer. That also goes the same way for the mean absolute deviation. The mean absolute deviation will always take into account that outlier. So it's going to fluctuate your answer. However, the IQR, or the interquartile range, only looks at the inner quartile. It only looks at the numbers in the middle. So it completely ignores extreme numbers that are small and extreme numbers that are big. So the IQR is completely unaffected by outliers. That is why it is the best measurement to use when you're calculating spread. So let's look at the example of the effects of an outlier on central tendency. Here we have a list of numbers that are the grades in math class: 98, 88, 92, 14, and 100. And if I was to calculate the mean, I would add all of these up and divide by 5. So that'll give me 392 because when I add all of these up, I get 392 divided by 5, which is 78.4. So looking at the mean, I will say that this person has an average of a C in the class. But that doesn't seem quite true. Let's look at the grades. A 98, a 88, a 92, a 14, and a 100. He has way more A's and B's than F's. But according to this, he's only a C student, or she's a C student. Why is that? It's because of the outlier. That outlier is giving us an incorrect answer. It's pulling the mean down. Let's look at the median instead. So if I put the numbers in order, be 14, 88, 92, 98, and 100. The middle number is 92, which is the median. According to the median, this student is an A student, which is more accurate looking at the list of his grades or her grades. So this is why the median is a better central tendency to use. It's not affected by the fact that the student only failed one assignment and got very good grades on the rest of them. And in this case, there is no mode. So we can't use that measurement. So looking at the data, the mean gives us a false answer, and we would make a wrong conclusion using the mean. Using the median, we're more likely to have an accurate answer. The outlier is the problem. This student received very good grades except for one time. So we don't want to make a conclusion about that student using the mean, because according to the mean, he's a C student or she is a C student. But that's not very true. The student only failed one assignment. The median is more accurate. He's probably or she's probably more of an A student looking at the list as a whole. So once again, I wanted to just show you what your notes should look like. You should have the title of the notes at the top, your standard, and your essential questions. Make sure you can answer these essential questions by the end of the video. And then you can start writing your notes. Notice how my notes are still in Cornell note style. Here I write the main part of the notes, and in the margin, I've written down some things that I want to remember or some questions I want to ask. And at the bottom, you should write 1 to 2 sentences to summarize the notes on this page. And if you need more room, you can always go to the next page. Here, I continued writing the notes. I wrote some questions down in the margin. And at the bottom, I will write my summary. Notice that I've written all the examples down, even some of the things that weren't directly written on the screen, but just something that was said in the video that's probably helpful for me to remember. And this would be another example. I've written everything down. And at the bottom, I will write my summary. So make sure that your notes are still in Cornell note style and that you are still actively taking notes throughout the video. That's it for this video, and I'm going to keep my promise and try to keep this video rather short since the last one was pretty lengthy. But before I go, I want to give you the motivational quote, and that is, hard work is a two-way street. You get back exactly what you put in.
So if you learned anything from this video, go ahead and give it a thumbs up. If you have any questions, suggestions, or comments that will make my videos more interesting and more engaging and easier to understand, just leave those below. Or you can just tell me in class, and I'll see you next time. Bye.